Okey. Ini kita akan buat tentang
Ini kita akan buat tentang bagi tugas lah. Tapi sebelum tu aku akan tunjuk dulu repeating instruction.
Edit screen dia.
Okay, basically kita punya depan itu untuk yang loop adalah MATLAB yang ringan lagi lah. Dia punya circuit kat sini, cuma kita just ikut je parameter dia semua. Okay, lepas tu kita kena ambil lah dia punya output dia. Contoh macam input ni kat sini, kita kata input. Okay, then kita ni lah, start dari tu dia ada start dia punya register macam ni, DVD 2 dan 3 lah. Okay, so lepas tu kita akan guna Microsoft Excel untuk kita plot dia punya graph. So start activity tu dia ada dia punya graph. Macam kat sini nombor 6, nombor 3 dan nombor untuk 3 untuk nombor 6 juga. Okay, lepas tu tak ada apa pun. Tapi kita tengok instruction dia. Okay, contoh dekat instruction juga. Okay, dia dekat boundary sheet sini lah. Kita kena buat 2 kali imam lah. So okay, nanti korang tengok lah dia punya dekat dia punya link ni kat sini semua 3 ni.
Boleh. Okay, lepas tu okay, sebenarnya tak ada apa-apa kot. Untuk pembagi tugas buat aktiviti 2 boleh? Boleh. Untuk aktiviti 1 ambil. Untuk aktiviti 3 kuat. Okay, nanti compile nanti kita bincang kemudian. Kita just bagi tugas dulu dan lepas selesai tu kita akan perlengkap lah. Okay semua? Baik. Okay, itu saja. Sekian, terima kasih. Okay, kita tengok pula yang dekat ni tu satu kan? Okay, untuk tu satu, kita tengok yang table tu bawah. Okay. Yang ni korang apa tu? Setting siap-siap lah. Macam contoh rated input voltage kan. Pergi kat input voltage tu kan?
Ya. Ni input voltage. Dan ni lah. Ni table 1, ni table 2 gila. Oh, sorry. Mana tahu banyak nak table.
Okay. Nanti play korang faham tak kan?
Buat benda ni.
Sorry. Okay, biarkan bosku.
Okay, jadi korang setting lah ikut dia punya parameter kat sini. Contoh sendiri dekat input voltage tu. Okay, nampak pada value dah 40 kan. Yang ni pun dah 40. So macam tu lah kalau ni setting lah, picture top apa semua setting semua kat situ. Okay, so contoh break kan. Kalau tengok result. Okay, contoh kan motor speed dia nak 400. Jadi korang setting lah situ motor speed 400. Faham?
Ni table 2 lah.
Ni table 2 pula. Okay, contoh kat sini 220. 400 kan. Situ lah. Faham? Okay.
Gitu. Break ni kosong. Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Mifidaz bin Azli. My material number is AE180039. I will present the activity number 1 for the open loop circuit control system, open loop speed control system. So basically, for this activity, there are 2 circuits that we need to design. First, we will look at the first circuit. I already construct the circuit. This is how it looks like. So for the circuit number 1, we use all these parameters and key in to the a circuit. So for the rated input voltage VA, it is 240, and for rated speed, it is 33,700. For the amateur resistance RA, it is 2.581. So we can look at here. This is where RA, we put RA 2.581. For the LA, this is LA 0.0281, and KM is 0.516. All of this is a part of electrical part, is in electrical part, and we arrange it in transfer function, same as a mechanical part. In mechanical part, we have JM, which is moment of inertia of motor, and we have BM, viscous frictional constant of motor. So, and we also have TK, which is tachometer constant. The value is 0.065, and also the another one, torque constant, which is 0.05 kT. Okay, so we, as shown in the procedure, record the waveform of the motor speed, the tachometer voltage, the motor torque, and the input voltage. So after we set all the parameter, we need to run the script. The script was running for 10 seconds. And first, we look at the motor speed waveform. This is motor speed waveform. Okay, we can look at here. This is the waveform of motor speed. And then it asks for the tachometer voltage. You can see here the tachometer voltage, same as the shape is same as the motor speed. Then we see the motor torque. Motor torque is here. At t equal to 1, the graph is decreased until 10 seconds. And then the input voltage. So this is the input voltage. At first, t equal to 0, it is 0. There is no voltage, but when at t equal to 1, the voltage is up to the 240 voltage, same as what we set here. Okay. So that is for the circuit number 1. For the circuit number 2, okay, for the circuit number 2, we need to use we are given a variable of motor speed in RPM, and based on that we need to find the value of input voltage and tachometer voltage. To find both values, we need to see at the input voltage and tachometer output here. Okay, so therefore we need to change the rate to 0 because we want the maximum rotation of the motor speed. Okay, for the 400, okay, we put here and we find a value 400. We run for 10 seconds. It's required in the procedure here. Okay, input voltage. Okay, so for the input voltage, this is how the waveform looks like, and this is the value of our input voltage. This is 26 volt, and we look at the tachometer output to find the tachometer voltage. This is how the waveform looks like, and our value is, you can see here, okay, the value is 25.96 volt. So for the 800, okay, input voltage. Okay, the input voltage is 52 volt, while the tachometer voltage is 51.92. It is like the tachometer voltage values are slightly different to the input voltage values. So that's how we find the input voltage and the tachometer voltage for the activity number 1 by varies the motor speed. So that's all from me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Aiman bin Ahmad Syukri alias Kapiten. I will present the activity 2, open loop speed control system. The objective of activity 2 is to observe the input voltage and tachometer voltage for different motor speed. So first, repeat step 4 in activity 1. Set the input speed to 2500 RPM and record input voltage. This is circuit for activity 1. So we must enter our input here 2500. Okay, and we run the simulation. After we run, we open the graph to see our value result. This is value that we managed to measure, 1.625 power of 2. So after we record the result in the table. Step 2 is repeat step 1 in activity 1. Set the input voltage to value obtained in activity 1. And in activity 2, set the brake to 0. Run the simulation, record motor speed at 10 seconds and record in the table. This is circuit for activity 2. So as you can see, we must input voltage that we've record in activity 1 here, 162.5. Okay, and brake we set to 0. Okay, after that we run the simulation. After we run, we see our graph speed output. So after that we see here our value 2.496 power of 3. So the value we must record in our table. After record, so we repeat the same step. We change the brake scale to 3. Okay, we run. So see the speed output, and this is speed output 2.265 power of 3. So we record in table. Now we repeat the same step until 21. Okay, so we run. So we see the result value, and the result is 8.790 power of 2. So after that we record in table. After we record the motor speed from the scale 0 until 21, so we must generate the result, the graph, motor speed vs again brake scale. From the result, you can see the motor speed RPM is increased. That's all for me. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Usman. Today I'm going to show you about the exercise tape for the activity. Okay, as you can see, this is actually the block diagram for the we need to implement in the BEF software. And then, okay, as you can see, we have the proportional gain, input voltage, saturation, brake part, brake, torque, meter, and constant. Okay, this is the parameter that is given, which is the proportional that we reset is 400. The saturation block is we need to 440, and the saturation block for the lower limit is actually 0. Okay. And then I'm going to show you the MATLAB. Okay, as you can see, we have instructed the circuit in this MATLAB. Also we installed 200 to constant meter 0.065. Okay, for saturation. Okay, I already installed 240 for the upper limit. For the lower limit, I already installed actually 0. Okay, for the brake, we can that. Okay, the input voltage that we need to install is actually in our activity 2, which is actually this meter is actually 100 to 162.5. The input voltage. Okay, and then we need to start step time 1. Okay, okay, and then we need to start it from the 0 for the brake scale 0, and then we need to key in the table 8.5 in the motor speed. This is motor speed for the output, which is we receive at here, speed output. Okay, and then we start from 0, and then we start. Wait for a moment to get to run. Fine. Okay, then we look at this output. Wait for a moment. Yes, you can see it's actually from the between 2.2 and 3, it's actually from this one. Then you can see that it's 200 to 2438. Okay, if we actually choose the brake scale, for example 9. Sorry. Okay, and then sport.
Also we got 2040.84. And then for the last result, let's multiply ke okay, we got actually 2073 for the speed of thread. And then we key in the table, this table that we receive, and then it will become like this. So okay, it will become like this. Okay, and then we need to compare the percent the square root 30 square root and compare with the step 4 indicator. So okay, this is the comparison that we get, which is in indicator is 55.53, which means it's higher than the result that we got in the indicator, which is it's actually 7.47%. That's it for me. Thank you.